About what? IPv4 address, right? So IPv4 is 32-bit address, the combination of 0 and 1. Like all 32-bit address is being divided into 4 octets. Each octet should be contain 8 bits. Each and every octet is being separated by using what? Dot. Like we clearly discussed how to convert from binary to decimal, right? 2 power 0, 2 power 1 values we clearly discussed here. Now, 0 indicates bit is off, 1 indicates bit is on. Similarly, how to convert from decimal to binary also we discussed, right? This all 32-bit address divided to 4 octet format. And IPv4 address range 0, 0, 0, 0 to 255, 255, 255, 255. Total, we have 2 power 32 combinations, which is 4.3 billion IP addresses. These all 4.3 billion IP addresses are being classified into 5 classes. Is class A, class B, class C, class D, and class E. So class A, B, C. Class A, class B, class C IPs are reserved for LAN and WAN. Class D IPs are reserved for multicast. And class E is a R&D, research and development. And which IP is a class A and which IP is a class B? How we can identify it? So based on ranges. Class A, class B, class D, all ranges are 0002 to 127 to 55 to 55 to 55 is the class A range. 128 to 191 is the class B range. 192 223 class C range. From 224 up to 239 is all IPs are used for multicast, which is class D IP address. From 242 to 55, these all IPs are research or development purpose, which is class E range. Like how we can differentiate means is based upon the priority bits. So from first octet, first bit 0 is being reserved for class A. From first octet, first 2 bits, which is 10 is reserved for class B. Like for class A, class C 110, 1110 for class D, 4 ones for what? Class C. These are priority bits. So now by seeing the ranges, we can understand which IPs belongs to which class and what is the purpose, right? ABC classes are being divided into network portion and host portions. So based upon our network requirement and host requirement, we can choose A or B or C. So class A, first octet is a network portion, remaining 3 octets. So class A, first octet is network, second octet is host, third octet and fourth octet. For class B, first 2 octets are network portion, last 2 octets are host portion. For class D, network, network, network and host, right? What about class D? And what about class E? So class D, no network portion, no host person. The class D for what? Multicast purpose. For class E also no network and host portion is a reserved for what? R&D, research and development. So we can say network and host portion only for what? Class A, class B, class C. Your requirement is a, if you require the more, very large number of hosts, you can choose what? Class A. If your requirement is a very few number of hosts, very few number of IP addresses, then class C is recommended. So based on number of networks, number of hosts, you can choose A or B or C classes IP addresses. Like how many networks in class A? So to find out, we have one formula which is 2 power number of network bits minus priority bit. The formula 2 power number of network bits minus priority bits. Class A 2 power 8 minus 2, 2 power 7, 128 networks. Out of 128, 2 networks are minus. Why? Because global ID and loopback ID. Global ID is used to for global identification is 000. Like all 4.3 billion IP addresses identification over 000. And one more for loopback ID. So loopback ID is used to check TCP/IP stack in your computer. In class A, 26 networks, 126 networks are valid. Class B, like 2 power 16. 2 power number of network bits, 16 minus priority bit 2, like 2 power 14 networks are available, like no minus 2 in a class B and class C. Like total 2 power 14 in B, 2 power 21 in class C is being what? Valid. So similarly, number of host calculation, so formula we use what? 2 power number of host bits minus 2. Class C example here, 2 power 8 minus 2, 256 minus 2, like 254 valid IP address per network. Here, why minus 2 we are doing here? For each network, you are doing minus 2, right? Which is very important question for interviews and which is very important question for Cisco certification also. In number of host requirement, in number of host calculation, why do we use minus 2? What's the reason, guys? Why minus 2 for each network in number of host calculation? Right, perfect. So one for network ID and one more for broadcast ID, right? Two IPs are minus. Valid IP address will lie between network ID and broadcast ID. Now, network ID and broadcast ID examples, if we take here, the class A example 10.0.0.0 and 10.255.255, between all IPs are valid IP addresses. Take a class B example 186.10.0.0 means the host portion, zeros in host portion is what? Network ID. 255 in a host portion is what? Broadcast ID. For class A also, 192.168.10.20 is a usable address. 10.0 is a network ID. 10.255 is what? Broadcast ID. Like here, first valid IP address, which is 192.168.10.1 is a first usable IP address. So generally based on what? Gateway purpose. Which is assigned to router, right? And how to identify network ID broadcast ID also had discussed. This is our last topic up to here we have discussed, right? So regarding the yesterday topic, do you have any doubts here? Have any doubts? You can text me now. All right. Let me continue today topic with the same IPv4 addressing. Let me take one example here. Based on that example, we'll discuss. We'll continue the class now. I've connected two computers. See, everyone, try to understand clearly. A few. First computer and second computer, PC1 and PC2, both are connected. RJ45 cable. Now for first computer, I'm trying to assign IP address is a 10.0.0.0. Can I use this IP address for computer? Can I assign it? No. Yes. Why? Because the network ID we cannot make use, right? Let me make use 10.0.0.1. I can use. Yes, we can use, right? Why? Because the first usable IP address, but generally, so 10.0.0.1 is recommended for what? To assign the computers or to assign the router? For router, right? We can use for computers also, but thing is recommended. So what I'm doing is for computer, I'm using 10.2. I'm skipping 10.1. I've reserved for router, right? So 10.0, 10.0.0.2 for first computer. Second computer have assigned 10.128 dot like 29.104. So first computer IP address is what? 10.0.0.2. For neighbor computer IP is what? 10.128.29.104. Now, whether both can communicate, guys? So like I have assigned the IP address. Can both PCs can communicate? Okay, all right. The next example, next scenario is a 186.10.2.9 for neighbor PC 186.10.11.3.9. Will they communicate, guys? Right. Next example, 192.168.10.10 for neighbor PC 192.168.11.10. Will they communicate? So these logics clearly we have to understand. Like which IPs can they communicate, which IPs cannot communicate. I mean, which IPs are on the same network and which IPs on a different network means. The first thing is here, in your office, in your LAN, within your office, like to enable communication between all devices should be in a same network. Like can use a class A also, class B also, class A also. But thing is the condition is what? Like all devices on the network should be maintained same network address. So generally, how we can find out same network or different network? Example here, 201, 202, 203, 204. It's normally in your flats, apartments. In general apartments, like if you, I'm trying to reach 203. So what is the mean by 203? What is indicates 203? So 203 indicate means what? So first two indicates second floor, plot number 3, right? So here two indicates floors, 1, 2, 3, 4 indicates room numbers, right? So more similarly, so floors are nothing but your network portion, rooms are nothing but your host portion. Like to enable communication between all devices, like all devices should be in a same flow. Flow should be what? Same. I mean same network portion. Now let me check our examples here. So first example is a class A or class B or class A IP address. Is a class A IP address, right? So for class A IP address, first octet is a network, second octet is a host, host, host. For neighbor PC, first octet is a network, host, host, host. Now let me check here. First computer is in a which floor, guys? The 10th floor. Your neighbor computer is also in the which floor? The 10th floor. I mean, both are in the same network or different network? Yes, they both are in what? Same floor. I mean, same network portion means yes, they can communicate easily. Okay. Host portion can be anything. The host portion here 0.0.0.2. Here 128.29.104. No issues actually, right? Condition is what? The two devices network portion should be same. We go first. Next example. Next IP address example is which class it belongs to? Class B, right? So for class B, 186 is a class B, right? So for class B, first octet is a network, second octet is network, third octet host, fourth octet host. For neighbor piece are same. Network, network, host, host. Now let me check here. First computer is a 186.186.10th floor. For neighbor PC, 186.11th floor. With 11th network position. Now both are in same network or different network, guys? Now both computers in the different networks, right? So will they communicate? So PC1 is telling is that you are in the different network portion, I am the different network portion, then how we can communicate, right? Now, last example, 192 is a class C IP address. So for class C, network, network, network host. N, H, right? First PC 192.168 10th floor. Your neighbor PC 192.168 11th floor. In the last example, both pieces in the same network or different network portion, guys? Different network portion, right? Means there are different floors, no communication actually. So what I'm doing is, let me change the IP address like 192.168.10.0. For neighbor also, I'm using here network portion. Let me make here 10 dot. Here also I'm using here 10. Now will they communicate, guys? No. Why? So why? Because same IP address means here IP address conflict will come, right? So first computer 192.168.10.10 for neighbor PC also 192.168.10.10. Like, can I repeat once again 202 one more room number in the floor? It's not repeat, right? So here also the condition is network portion should be same. Network portion should be what? Same. The host portion should be unique. The first PC 10 means here is what? 19. 190. Like this. So these conditions, these logics we need to keep in mind when you are working in the real time. Now for first computer have assigned IP address is 224.10.10.10. For neighbor computer 224.10.10.11. Will you communicate, guys, now? No. Why? Because 224 is a what? Class D IP address. So can you at least we use can you assign this IP address for the computers? Not make use, right? Let me show you the small practical actually. Let me try to assign IP address to 224 for my computer. Right click on LAN properties, IPv4 properties. Now if I'm using 224, what one error? Is the error 224 is not valid entry. Please specify a value between 1 and 223. Because up to class C address, which is 223 only, we can use, right? The next point is a 127.1.1.2, 127.1.1.3. Will they communicate, guys, now? Very good. Rakesh, Nikita. See, 127.1.1.2 means is a which class IP address, guys? Actually, is a class A, but 127 network is being minus, right? So what is the purpose of 127 IP address? Is being reserved for what? Loopback. The IP address is only for testing purpose to check the TCP/IP stack only, right? So even 127 we cannot make use it. 127 is minus, right? So let me try to assign 127 IP address. Even you can check from your computers also. Try to assign 127, 127. The error message here, right? There is IP address starting with 127 are not valid because they are reserved for what? Loopback addresses. Please specify the mother valid between 1 and 223 means what? Even 000 is also not usable network, right? Not used for clients. 0 dot. These are the logics you need to keep. Next logic is the yesterday class and today class and coming classes. Whatever present. What topics I'm going to start now, which is very important. The complete IP address and network communication system is happening based upon this topic only. So try to more focus on it. Let me start now. Getting? I'm clear? Can you please respond? All right. So let me start here. Try to focus on it. See, computer 1 and computer 2. Two devices are connected. For first computer, 10 dot 0 dot 0 dot 10 IP address have assigned. For second computer, 10 dot 0 dot 0 dot 20 have assigned. For next example, 186 dot 10 dot 20 dot 19. Neighbor computer 186 dot 11 dot 20 dot 19. For next computer, next example, 192 168 1 dot 20 192 dot 168 dot 2 dot 20. Now tell me guys, in first case, this IPs belongs to which class? Class A. Okay, right. Now first PC and second PC, will they communicate? Yes. Why? Because both are in what? Same network portion. Very good. Perfect. The second case, 186.10.20.19 belongs to which class IP address? Class B. Will they communicate, guys? No. Very good. Okay. They don't communicate. Why? Because different network portion. The last case, which class IP address? Class C. Perfect. Now, in the last case, both pieces can they communicate, guys? No. Why? Because different network portion. Right. Very good answers. But now my question is, how we can tell first case 10.00.10 is a class A IP address. The second case 186.10 is a class B IP address. How we are telling is, guys? How we can say it? So based upon the class ranges, right? First octet class ranges from 0 to 127 is a class A. Like 128 to 191 is a class B. Like based upon the ranges. As a user, the ranges we can understand and we can compare. So both pieces are the same network or different network, right? As a user is okay. But main thing is we used to work with devices. We used to work with what? Devices, but how machines can understand, how device can understand. Like how PC1 will come to know this IP is a class A. How PC1 will come to know neighbor computer and my computer both are in the same network, we can communicate. And how machines will come to know 186.10.1.19 is a class B address, and neighbor PC and my PC both are in the different network communication, different network, we don't communicate. How machines can understand it. As a user, we can come to know, okay, but what about machine? This is very important logical. How device can understand it means, so devices can understand based on network portion and host portion. Let me explain clearly network portion, host portion about class A, class B, class C addresses. So first let me take class A example. Class A, first octet is what? Network. Second octet, host. Third octet, host. Fourth octet is what? Host, right? And IPv4 is a combination of what? 0 and 1 binary. 1 indicates network portion, 0 indicates what? Host. Host bits, right? 1 indicates network, 0 indicates what? Host. Each octet is 8 bits. 8 bits, 8 bits, 8 bits. Now, network indicates what? Zeros or ones network indicates? Network indicates what? Ones, right? Means 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. Host indicates zeros, 8 zeros, 1, 2, 3, 4, 5, 6, 7, 8. Host also what? 1, 2, 3, 4, 5, 6, 7, 8. Last one, 1, 2, 3, 4, 5, 6, 7, 8. So by seeing this address, your machine can understand network portion and host portions. So these were binary language for the machine. What about user can understand? The converted decimal. All ones value is what? 255 dot. All zeros. 0 dot. 0 dot. 0. So this we call it is a subnet mask. So based upon subnet mask, your machines can understand which one is a network position, which one is a host position. Now here finally 255 indicates network position, zeros indicates what? Host position. So by seeing the 255 0, now machines understand which one is a network position and which one is a host position. So generally the class A, right? But we know first octet is a network, second octet is host, third octet is host, fourth octet is host, but we know it. But how machines can understand? Based upon what? Subnet mask. If we assign subnet mask like 255.0.0.0.0, then only my PC can understand this is a class A and first octet is a network portion. Remaining all octets are host portion. If we are not assigning subnet mask, your machine does not know which one is the host portion, which one is a network portion, actually, right? For a neighbor computer, subnet mask is what here? 255.0.0.0. Now neighbor PC can understand, okay, first octet is what? Network portion. Remaining three octets are host portion. Now PCs can understand. So I am a 10th floor. I am a 10th network. What about your neighbor? Yes, neighbor, I am also 10th floor. We are the same floors. We are in the same network position. We can communicate. Now, similarly, next example for class B, what will be the subnet mask of class B? Perfect. So class B, 255.255.0.0 because network, network, host, host. What about class C? Right, 255 dot 255 dot 255 dot 0 because three network portions n. So while you're assigning IP address to your computers, along with IP address, we have to assign what? Subnet mask also. So by seeing the subnet mask, machines device can understand which one is a network position, which one is a host position. Now here second example, class B, subnet mask is what? 255.255.0.0. Like after assigning subnet mask, now my machine understand 186 is a network position and 10 is also network position. If you don't assign the subnet mask, then how my PC can understand 186 10 is the network portion and 2019 is a host portion? How my machine can understand? Not possible, right? So devices are understanding based upon what? Subnet mask is a very important key role in your logical algorithm, right? Your neighbor PC in 255, 255, 00, 186 is a network, 11 is a network portion. First PC is a 10th floor, and neighbor PC is what? 11th floor. So neighbor, we are not in the same network, we are in the different floors, different network portions, we don't communicate. So still we can communicate by using a mechanism called what? Router. So what is router? So router is a hardware device which enables communication between two or more different logical networks. So actually 192.168.1.20, 192.168.2.20, both are different networks, right? Logical networks, both are different logical networks. How we can communicate? So still if you want to enable communication, both IPs can communicate via which device? Via what? Router only is possible. So your computer IP address, my PC IP address is 192.168.0.7 is one network, one logical network. But now, how many websites, how many servers I can access in the internet? Number of networks I can access, right? So how is possible means my complete laptop, my office, my computer traffic is going via which device? What? Router. How it is going to do the job that we are going to discuss clearly on about how router exactly enabling different network communication, how it maintains the tables or IP address information. Subnet mask nodes can copy. Subnet mask differentiates network and host portions of an IP address, represented with one's network portion and the host zero sim portion. Example, right. So let me continue with IPv6 address. So regarding IPv4, do you have any doubts? Let me do one thing. All of you open your chat box. Keep ready texting. My first question is here. 92.81.2.9. This IP address belongs to which class? Very good. Class A. Now, what will be the network ID of this address? Network ID. Perfect. 92.0.0.0, right? So what will be the broadcast ID? All right. 92.255 255.255. Now 92.81.2.9, is it valid IP address? Yes or no? Yes, is valid IP address. So what will be the subnet mask of this IP address? Subnet mask. 255.0.0.0 subnet. Perfect. All. The next question is 172.16.0.2. Which class IP address it belongs to? Which class IP address? Class B, right? So class B IP address, what will be the network ID of this IP address now? 172.16.0.2. You know how, come on. Still few people are getting confused. Clearly discussed, right? Today, class B network ID is a 172.16.0.0. Host portion. Zeros in host portion is what network ID? Broadcast ID, guys. 172.16.255.255. Subnet mask. Oh, wait. 255.255.0.0 is the subnet. Correct. 192.168.2.10. Which class IP address? Class C. Network ID. 192.168.2.0. Someone is means 192.0.0.0. It's not a class C, right? It's not a class A. Class C. First three octets are network portion. Host portion 0. Broadcast ID, guys. Yeah, 192.168. 2.255 is a broadcast ID. And finally, what will be the subnet mask of this IP address? Okay. 255.255.255.0, right? So I hope you have a very good knowledge on now IPv4 addresses. Very good enough actually to work with the real time. Now let me continue with IPv6 logic, same like IPv4, like how what we have discussed IPv4 logics, same thing we'll discuss in IPv6 also. So IPv6 is only for next generation purpose, but still we'll discuss about IPv6 also. But in IPv6, no class A, no class B, no class C, no class actually. But how we can understand that? Let's be ready first. IPv6. IPv4 is a how many bit address? 32-bit address. For 32-bit address logics to discuss, we got is a two sessions, right? Yesterday and today continuation. But now I'm going to start with 128-bit address. Let me see how much time will take it. How many days will take it? 128-bit address. So to discuss 32-bit address, we do the two sessions, right? Let me see now. 128-bit address. IP address, two versions. One is IPv4, IPv6. IP version 4 is 32-bit address, and IPv6 is what, guys? 128-bit address. So 32-bit address is being represented in a decimal language, right? It's a combination of 0 to 9. But IPv6 is a combination of hexadecimal. IPv6 represent in what? Hexadecimal is similar to mathematics. Hexadecimal means 0 to 9 and 8 to F combination. Here all 32 bits of IPv4 address are being divided into octet format. One octet is equal to 8 bits. Like how many octets are being divided IPv4? 4 octets is 32 bit address. What about IPv6? Like IPv6 128 bits are divided into quartets. Like one quartet is equal to 4 hexadecimal numbers. Like similarly, we require 8 quartets. Like 8 quartets equal to how many hexadecimal numbers, guys? One quartet is a 4 hexadecimal number. Like 8 quartets. How many hexadecimal numbers? 32. 32 hexadecimal number is a IPv6 address. In IPv6 address is a hexadecimal combination of 0 to 9 and 8 to F. We require how many hexadecimal numbers? 32 hexadecimal numbers arranged in 8 quartets. In IPv4, first quartet, first octet, second octet, third octet, fourth octet. Each octet is being separated by using what? Dot. But in IPv6, first quartet, second quartet, third quartet, like 8 quartets are being separated by using colon. What? Colon. See the notes? IPv6 address is 128 bit address. It is represented as 32 hexadecimal numbers arranged in 8 quartets. 4 hexadecimal digits separated by using what? Colon. Like first quartet, second quartet. Example of IPv6. The main thing is A, B, C, D, E, F. No case sensitive. You can use uppercase also, you can use the lowercase also. No case sensitive. Copy form. Next point about IPv6 address is IPv6 address is what? Hexadecimal number, right? Like one hexadecimal equal to 4 bits. Like 4 hexadecimal numbers. Four hexadecimal numbers equal to 1 quartet. Okay, like 8 quartets equal to IPv6. For 3 points we'll discuss now. What's the point number 1 here? Point number 1 is 1 hexadecimal is equal to how many bits, right? 4 bits. So first let me write hexadecimal number. Decimal numbers are what? 0, 1, 2, 4, 5, 6, 7, 8, 9. And 11, 12. Hexadecimal number. So 1 hexadecimal number is equal to how many bits, guys? 4 bits, right? Like how you can write it now? Just use the formula. Is 2 power 0, 2 power 1, 2 power 2, and 2 power 3. So 2 power 0 value is what? Any power 0 is a 1, 2 power 1, 2, 2 power 2, 4, and 2 power 3 is what? 8. Values are now, we got values here, 8, 4, 2, 1. So 0 means 8th bit. This first bit is a, it should be off. And 4 is should be is off. And 2 should be is off, right? And 1 should be is what? Off. So 0 indicates 4 zeros. What about 1 indicates? Like 0, 8 should be is what? Off. 4 should be turned off. 2 should be off. And 1 is on bit, right? Like 2 you can indicate is what? 2 value is on. Remaining all are what? Off. Turn off. And 3. Yeah, let me explain clearly. Understand clearly now. 3 indicates what? How we can write the 3 means? 3 means what here? 2 plus 1 is a 3, right? 2 plus 1 is what? 3. Means 2 place use 1 and 1 place use what? 1. Remaining are what? 0. 0, 0, 1, 1. Example 4. Fourth bit is turn on. Remaining are what? Off. 5. How can I write the 5? 4 plus 1 is a 5, right? Means fourth bit should be on and 1 should be is on. Remaining are what? Off. Turn off. And what about 6, guys? 6 is a 4 plus 2 is what? 6, right? Means 4 is on, 2 is on, remaining is what? And how can I do this 7? 7 is a 4 plus 2 plus 1 is 7, right? Means it should be off 1, 1, 1. And 8 is 1, 0, 0, 0. And how can I write as a 9? 8 plus 1 is a 9. So 8 is on, 1 is on, remaining should be is what? They are getting Mirage. Mirage something. Login as a mean. Now 10. So generally 10 is what? It's A, it's B, it's C, D, E, and A value. Like again the same 8, 4, 2, 1. A value is what guys? 10, right? Means 8 plus 2. 8 plus 2 is 10. Means 8 is on, 2 is on. Remaining bits are what? What about B? 8 plus 2 plus 1, 11, right? Means 8 is on, 2 is on, 1 is on. See, 12. 8 plus 4, 12, right? See, 13. 8 plus 4 plus 0 and 1. 14. 8 plus 8 plus 4 plus 2 plus 0. Finally, 1, 1. So this is the first point here. One hexadecimal number indicates what? 4 bits. Here. Let me do some examples. This is a chart here. I'm going to convert from binary to hexadecimal numbers. 8, 4, 2, 1. 8, 4, 2, 1. Let's consider this is first value. Next, 8, 4, 2, 1. Second value. 8, 4, 2, 1. First example. 8 plus 4 plus 2 plus 1, right? All ones. Is a 15. 15 value is what? Hexadecimal is? Yeah. Second example. 8 plus 4, 12 plus 1. 13. 13 indicates D, right? First value is a D. Next value. 8 plus 2 plus 1, 10 plus 1, 11. D, B is answer, right? Next example. 1011. 1011 is B. Okay. 0001. Only one. 1010. B1A, right? Next example. 1011 again, it's a B. 1010 A. 1011 again B. 1010 against what? A. B. Baba. Next example. 1100. 11 is a 8 plus 4. 8 plus 4. 1 first value is 8 plus 1 is a 4. 8 plus 4 is what? 12. 12 value is what? C 1010 A. All ones. F 1110. It's a E, right? Okay. I'm repeating two more examples. Just try to concentrate here. See, 1, again 1, again 1. 4 ones means What's the value, guys? Put one's value is what? F hexadecimal. 1010. 1010 is right? A, right? 1010 is what? A. 1100. Once 1100. So here, come here. 1100 is what? T. Value is what? X. Taku is joined from Banjara Hills. 68650. I'm getting the point. 665 from ID. Banjara Hills. Last example is what? T3, T5. Like we can convert from binary to hexadecimal. Certainly, hexadecimal to binary also can convert. The most important thing is how we can understand 128-bit IPv6 address. So to represent a 128-bit IPv6 address, some rules are available. Let me discuss clearly about the rules. Let me take one example of IPv6 address. First point, okay, one hexadecimal is 4 bits, and second point is what? 4 hexadecimals. Second is what? 1 quartet. Let me write 4 hexadecimal number. 4 hexadecimal is 2, 0, A, 9. 4 hexadecimal numbers, right? This we call is 1 quartet. Okay, or else like a 2, 0, 0, D. 4 hexadecimal numbers. This is 1 quartet. The second quartet, 0, 0, 2, 3. First quartet, second quartet is being separated by using what? Colon. Okay, colon 0, 0, 0, 0. Third quartet. And fourth quartet also writing is a 0, 0, 0. Okay, I'm writing here 0, 0, 0. Now, how many quartets have been finished? 1, 2, 3, 4, 5. So 3 more are required. Let me write 3 more here. 0, 0, 0, E, colon 0. It's my example. You can take your own examples, but to explain easily, I'm using this example here. So this is one IPv6 address. This is 128-bit address representing 8 quartets. Each quartet should be contain 4 hexadecimal numbers, right? Total 32 hexadecimal numbers. So how we can understand this IPv6 address means we have some rules to represent IPv6 address. What the rules are? Let me clearly discuss the rules. Rule number 1. So rule number 1 is a from any quartet of IPv6 address, from any quartet, leading zeros. You have any leading zeros from any quartet can be omission or can be omitted. Can be removed actually, right? Can be omission. Only leading zeros. Means the first quartet 200D. You have any leading zeros here? No leading zeros, right? The same quartet you have to same to write same. Let me write here 200D. Cannot do anything for the first quartet. Colon. For second quartet 002C. Means here we have 2 leading zeros, right? We can omission that. Then directly can write as what? 2C. 2C also. Only leading zeros have been what? Omitted. Colon. This is the rule number 1. Rule number 1 is what? Leading zeros can be omitted. Now, second rule. Rule number 2 is a from any quartet 4 successive zeros. Now, the continuous 4 zeros. So four successive zeros can substituted by 1 0. The four successive zeros, has been substituted by what? Can write as what? 1 0 colon. Again, four successive zeros, 1 0. Again, four successive zeros, 1 0 colon. Again here, the fifth quartet, sixth quartet, we have the leading zero, four successive zeros are available here. We don't have any four successive zeros, right? Only here leading zeros are available. Then what we'll do? Just mention the leading three zeros, and I can write as what? E, four successive zeros and four successive zeros. 0 colon 0. That you can represent IPv6 address. Getting? The rules. Rule number 1, leading zero in any quartet can be omitted. Four successive zeros in a quartet can be substituted by what? 1 0. But only two rules. One more rule is available. So the next rule is multiple fields of zeros. Multiple quartets of zeros represent with double colon. Multiple fields. There can be two fields or three fields or four fields, like multiple fields indicates represent with what? Double colon. Double colon indicates multiple quartets of zeros, multiple fields of what? Zero. Now you tell me guys, how can represent this IPv6 address here now? Like 200 D colon 2C. Multiple zeros means here three fields of zeros, right? Doesn't mean what? How we can represent here? Colon, colon, colon. Three colons, right? No. Is it three fields or four fields or four fields? Like any multiple fields can be represented with what? Double colon only. Like here, three fields. Okay, you can go for three colons. Not like that actually. Only double colon. Double colon. E. Again here, multiple fields, right? Use what? Double colon. So this IPv6 address we have assigned to one computer. Now how my computer can understand, guys, here? So PC, what PC can understand? Okay, I have assigned by IPv6 address. IPv6 address should be how many quartets? 8 quartet, right? So actually 8 quartets, but here we have configured how many fields, guys, here? 1, 2, 3. 3 fields only have assigned, right? Now how many are missing here? How many are remaining? 5 should be there. Then where is the 5 fields? So where is the 5 fields? In double colon. But in my example, here we have a double colon. Here also we have what? Double colon. Then how my PC can understand where exactly 5 fields? So there is a chance device can understand. Here maybe 2 zeros. Here maybe 3 zeros. Maybe here 3 zeros. Maybe here 2 zeros, right? The device will get confused. So this is invalid IPv6 address. Then which is a valid IPv6 address is? So why? Because invalid means we cannot repeat multiple times as a double colon. So double colon can be used only once in a address. So either it can represent in the first place, either it can represent in a last. The first either lost anywhere you can represent actual, right? But where is the recommended? Instead of replacing two fields, better to replace with what? Three fields. But double colon should not be repeated only once in a address. Finally, it was a logic or is a IPv6 valid IPv6 address is 200B colon 2C double colon E colon 0 colon 0. So this IPv6 address, if we assign to device, now my device will understand 1, 2, 3, 4, 5 fields are available. Remaining how many are missing, guys? 3 should be there. Then now automatically my PC can understand where is the double colon. So there 3 fields of zeros are available. The device can be understand automatically. Okay. So this is a logic of IPv6 address. The next rule is replacing successive fields of zeros with double colon. Multiple quartet with zeros can be represented as what? Double colon, but only once in a address. Copy it. This is an example. Let me do some practicals, some physics, replacing of successive fields. Here, first example. You can represent, guys, first example. 2001 colon leading 0 is being omitted. And write DB8 colon leading 3 zeros are being omitted. That is a 1 colon. And the next quartet should be right as is 10000 and 2 fields of zeros you can represent with double colon. Again, leading 0 is omitted. You can write as a E of 0 colon BC 00. So this address if you assign to one device. Now my device can understand here we have how many fields? 1, 2, 3, 4, 5, 6 fields have been assigned and remaining 2 fields. So where we have multiple, where we have a double colon. So there we have what? 2 fields of zeros are available. the device can automatically analyze. Now, next example, 2002 colon 2002 colon 1111 colon 4CF, like all fields, multiple fields of zeros can represent with a double colon. And last finally, two zeros are being leading. You can omit it. You can write as what? 2F. And if you assign a IB for device, now device understand 1, 2, 3, 4 fields are being assigned. Remaining 4 are missing. So where we have a double colon, there we have what? 4 fields of zeros are available. Okay. You can take the screenshot of it and you can practice for remaining addresses. 4 addresses. Right. Okay. All right. Next logic, let me discuss in IPv4. Two computers here, computer 1 and computer 2 together. The first computer IP address is 192.168.1.10. The second computer IP address is 192.168.2.10. Will they both can communicate, guys? No. Why? Because both are in what? Different network position, right? Okay. Now 192.168.1.10 have assigned. Will they communicate, guys? No, IP address conflict will come same addresses. Okay, now let me change now. 1.1.20. 1.10 for first PC, 1.20 for second PC. Will they communicate? Yes. Yeah, we have very good logic now. Very good. Very good. The next question is for first computer 2020 AF colon double colon 20 AF colon 2CF double colon 1. For next computer IP address is a 20EF colon 2CD double colon 1. Will they communicate, guys? Maybe. Right. Not answer. The next one is a 2C, 20EF, 20AF, and 2CF. Both sides 2CF, 2CF, colon 1. Will they communicate now? Maybe. Or no? Yes. Let me check now clearly. But in IPv4, we got the logic. So IPv4, we know which is a class A or class B or class C, and which one is the network position, which is the host position. By comparing that, we can understand easily, right? So what about IPv6? In IPv6, no classes, no A, no B, no C, right? Then how we can understand the same network or different network position means? So first, let me write this IPv6 address in 8 quartet format. Let me write 8 quartet, like 20AF colon 2CF colon 0 colon 0 colon 0 colon 0 colon 0 colon 1. the 8 quadrant, right? Now for second example, same address. The only difference is here 20 EF, right? 20 here is what? E, yeah. So IPv6 address is a 128-bit address. Out of 128-bit address, first 64 bits and second 64 bits. Like first 64 bits indicates network portion, like second 64-bit indicates host portion. Like out of 8 quartets, first 4 quartets, first 4 quartets indicates what, guys? Network portion. First 4 quartets indicates network portion. Now let me compare the both computers. So first computer 20AF 2CF00. For neighbor computer 20EF 2F00. Now both are in same network portion or different network portion? Both are in what? Different network portion. Now will they communicate, guys? No. So like this, IPv6 address also we can understand logics clearly. Whenever you're working with IPv6 address, now make sure that your all computers in the LAN first is 64 bits. I mean, first 4 quarters should be same for all your computers devices in your network. Now both are in a different network position, right? But still you want to communicate. How is possible? Perfect. So even IPv4 different network communication, even IPv6 different network communication, they can communicate via device called what? Router. The router is a device which enables communication between two or more different logical IPv4 and IPv6 networks. Now, if I change here, if I change here also 2EF, 20 here, EF I'm writing here, EF. Now both can communicate, guys? No. Why? So here also the logic is what? IPv6 or that conflict will come, right? It is conflict. Yeah, host portion also what? Same here. Another network portion, host portion also what? Same, then conflict will come. So what the logic had discussed in IPv4, in IPv6 also, network portion should be same, host portion should be unique. See here, network host portion is what? 4 quarters, right? Out of 4 quarters, you can change from any quartet. Not only last quartet, I can change in a like a fifth quartet or sixth quartet or seventh or eighth, whatever you can change it. Let me change here. Last quartet have added is a 1E. Now, yes, they can communicate. Here 1 is a 1E. Can communicate, right? So like this logics we can understand quickly. Let me show you how to assign IPv6 address for your computers. Like how we have assigned IPv4 address, same thing like IPv6 also. Right click on your LAN adapter to property. Just clicking on IPv4, just click on IPv6 and go to properties. Here you can change. Fine. Example 2001 colon 2CF double colon 1 like this. This is my IP address. Out of 128-bit IP address, how many bits are network portion? Bits are network portion, right? 64 bits, right? So these 64, technically we call it is a subnet prefix length. Subnet prefix length is what? 64 is the default. Tab you can get automatically. Means here the link is a slash 64. Slash 64. So So here slash 64 indicates we are telling is that first 64 bits are network portion. Even slash 64 is the default if its length, even we can change it actually. Upon a requirement, we can change. We can customize. So for customization purpose, we can do it. We can copy it. First 24, 64 bits are. Yeah, even you can change here 32 also. Number you can increase the value or you can decrease the value. Based on your requirement, you can customize it. Default is 60. Hello, can you hear me, guys?
Yes, sir.
Is my voice is louder? All right, okay. This is all about IPv6 logics. Okay. Any doubts regarding IPv6?
Do we discuss about this topic to the change of prefix for PV6 in future
We can
classes?
change it. We can change. Default is 64, right? Instead of 64, if we do is a 32, now that machine can consider first 32 bits are network portion. Whereas if we change as a like a 60, what my PC do I can understand? Okay, first 60 bits are what?
When your boss is
Depends upon your requirement actually. You want to make, you want to customize it, you can do it. It can be supported. Where we use means is optional. What would you say? Want to try it? Hello, can you hear me, everyone? Is my voice is clear now?
yes, sir.
Yeah,
Sometimes it's
actually, there
going
is an
on.
optional. Is optional. You want to utilize it, you can utilize it. Actually, the default is 64. Uh, Option is there. You want to utilize it, you can utilize it. Or else you can default 64 bits is a for 64 bits or what network portion.
So again, this is nothing but again we are in other ways we are again classifying it in class ABC.
No, no, we are not
Something
defining
like
any
that
classes
only.
here. Actually, we are not defining. See, class B, A, B, C are divided for what purpose?
Yeah, to have more
Network
networks
portion, host
or
portion.
to have more hosts. Same thing, right? Even in class in IPv6 also, when we are changing that slash 64 to slash 32 or 8 or 16, whatever, that means we are reducing the network and increasing the host.
Even like that only. We are reducing network means we are increasing what host
Increase
host
the
only.
host. So that is exactly like instead of calling it, there is no classes, but in other words, we are putting it as classes only. Class A, class B, class C.
Similarly like that.
Okay. All right.
Okay. And again, back to IPv4 addresses. Let me ask you some questions about IPv4 address. In IPv4 address, 0.0.0.0, we call is a which address? It's what we call it is a global ID, right? Global ID, or we can call it is a default ID. What about guys 127.0.0.0? We call what? Loopback ID. Perfect. Now 224.0.0.1. Which IP address it is? Right. It is a multicast address, right? Multicast IP. So we have some special IPv4 addresses like a global ID, loopback ID, multicast address, and APIPA IP address. Also, we have some IP addresses ranges there actually. So similarly, two or more devices, three devices, four devices, that are connected to switch. We call it is what? Network. Local network is LAN, and switch connected to router to communicate different network communication. Router connected to internet via ISP. Now, internet is what? Public network. Everyone is connected to that. So, in internet is public network, a local network. We can use which class IP addresses, guys? Can use a class A also, class B also, and class A also. ABC class. So, from ABC classes, we have some IP addresses called private IP address and public IP address. So where we use private IP address and where we use public IP address means private IPs are used in private networks. The name itself is saying is what? Private IPs are used in private networks. Example, within LAN. Within your LAN, we use what? Private IP address. Or within a office, within a organization, we use a private network which what is a private network. And where we use public IP addresses means the public IPs are used in public network, which is public network is a internet. Internet is a public network. Public IPs are used in the major important point is here. Your private IPs are being assigned by network administrator. We can use it like A or B or C based upon your number of networks required or number of hosts are required. You can use A or B or C for private network. Now, what about public IP address? Like public IPs, all public IPs are being registered from service provider. So public IPs are provided by what? Service provider. INA is being registered, right? So to get internet access, generally we are paying, right? For service provider, we are paying. Why we are paying for service provider? Why? Why? The reason is we are purchasing public IP. So our all LAN users can reach internet by using public IP only. We are getting internet means public IP we have. So public IPs are we need to purchase from service provider. Private IPs are the differences here. Public IP and private IP address. Public IP address used on the internet, signed by internet service provider, need to purchase from service provider. About private IP address used within the organization, which we call LAN or private network, signed by network administrator. These IPs are what? Free. But we clearly discussed Class A IP address range is what? 0 to 127. 0 is global ID, 127 is loopback ID. So leave it at 0 and 127. Please consider 1 to 126. And Class B, 128 to 191 address range. For Class C, 192 to 223, right? But which IPs are public IP address? Which IPs are private IP address means we have a specific ranges for from Class A and B and Class A range is 1 to 126. From this range, IP starting with 10.0.0.0 up to 10.255.255.255. Complete range is a private IP address range from Class A. So Class B range is what? 128 to 191, 172 dot 16.0.0 to 172 dot 31.255.255. Class B private IP address range. Class B private IP address range. Similarly, for Class C, 192 to up to 223 is actual range. From this range, IP starting with 192.168.0.0.2, 192.168.255.255. It is Class C private IP address range. Now we got in clarification, right? So which IPs are private IPs and which IPs are public IPs. So other than private IP address, remaining all IPs are what, guys? Public IP address which are registered from service provider. So those IP address we need to purchase from internet service providers. So first example, 168 dot 16 dot. First example is 116.15.19.20. This IP address is a private IP address or public IP address? Public. Perfect. 10.0.0.10. Is it private or public? Private. 192, 169, 10.16. Public IP or private IP? See, IP with 192, 168. 192, 168 is only private IP, but my question is here 192, 169. Public IP, right? Now, what about 193.168.0.1? Is it private IP or public IP? Public IP. Perfect. 172.32.16.10. Public or private? So like that, we can understand which IPs are class A, which IPs are class B, which IPs are class C, which IPs are network IDs, which IPs are broadcast IDs, which IPs are valid IP address, and which IPs are private IP and which IPs are public IP, and which one is a subnet mask for class A and class B, class C. Like it's all the logics perfectly we know right now. Yes or no? Clear? All the logics are you okay? Right. So by using these logics only, now we can easily work further technologies.
Sir, I have a question.
Yes, please.
Question number one is, can we use 0.0.0.1?
So you can't use any IP starting with 0 or 127 and that 224.
Okay. So it should start with 10, 1.
Start with 0. The start with 1 only valid.
Okay. But those are also representations only, right? I mean, I'm curious, but 0.0.0.1 means at least it's number one. Like,
Even we cannot make use any IP 0, 0, 0, 0, 2, 0, 255, 255, 255. Between all IPs are being wasted. We cannot use it.
okay. Any use of having these private IPs like as classified as you're showing like
Within the LAN for security reasons, we use generally private IP.
we can use can't we use public IPs as private IPs also within a LAN?
Even we can use a public IP in the LAN also, but we can't use internet. As long as you are not connected to internet, then you can use public IP also in your LAN. No problem, not an issue. But when you got internet connection, then we cannot make use public IP address without registration,
Without a router.
without service provider, without registration. Use
Oh,
internet.
without a router, we cannot have 10 public IPs within our same LAN and communicate to each other. We
Yes,
can.
we can communicate.
Uh,
We can communicate. See, the thing is, this is my office computers. One, two, three, four. Have a number of devices connected. So to enable communication for these devices, you can use A, B, C class IP addresses only. From A, B, C, you can use private IP also, you can use public IP also, not an issue, no problem at all. As per our conditions, should be the same, no problem at all. The thing is, when these users needs a internet, what we'll do for internet access, we connect what? Router.
router.
Router to what? ISP. And connectivity. ISP to what? Internet, right?
Internet.
So when they happen like this, now in the LAN you have to make use which IP address now? That is only private IP.
Will there be any conflict if we use public IPs here also? It's just-
So,
and also connected to internet. Will there be any conflict?
yeah, no conflict, no conflict.
Sorry, sir. Yes or no? No conflict. So this is only a nomenclature. Like, is it like good practice?
Yes. Yes, you can use same private IP for two companies. There's no problem that way. But even that case, the thing is, I'm using for my laptop IP is 192.168.1.10 something. It can be your computer also. Maybe our online participants, anyone can be used this IP. So class A, class B, class C, we have private IP address range and we have remaining all our public IP address range and global ID, loopback ID, multicast address, private IP, public IP. These all are in a IPv4 address. What about IPv6 address? In IPv6 address, also we have a global ID, loopback ID, multicast address, private IP address, public IP address. The terminology is different we use in the IPv6. We don't call it as a private IP and public IP. We have a different terminology in IPv6 address. Let me see what we call in IPv6 address here. In IPv4, we have private IP address, public IP address, IP4 address, multicast address, loopback address, and default. This is global IP. These are about IPv4. In IPv6, private IP address, we call in IPv6 is a unique local IP address. Public IP address, which is similar to in IPv6, we call it is a global unicast. IP5 is a link local, multicast is same, loopback is same, and default is same. So IP address, any IP starting with 2 or 3. Any IPv6 address, I repeat once again, any IPv6 address starting with 2 or 3 is public IP, is global unicast. Like any IPv6 address starting with FC or FD, these IPs are unique local, which is private IP. Like any IPv6 starting with a FE, which is linked local IP. Mostly two addresses are enough. Any IPv6 address starting with a, like we example we took 2001 colon 2CF double colon 1, right? So this IPv6 address starting with a which number here? 2, right? So any IPv6 address starting with 2, this IPv6 address we call what? Global unicast. If I write IPv6 address is a FD colon 29D double colon 2. So this IPv6 address is starting with FD means this IPv6 address is a unique local, is similar to what? Private IP address. First you can copy all of IPv4 and IPv6. Copy? Right. It's all about IPv6 address and IPv4 address. Here it's showing some IPv6 address, right? P80. Starting with which letters, which letters from here? FP, right? Any IPv6 address starting with FP80, this IPv6 address we call what? Link local, which is similar to APIPA, automatic private IP address. Right? This IP will communication. Already default in the local machine. Same like any IPv6 address starting with 2 or 3. IPs are global. Any IPv6 address starting with FC or FD. Is it clear, guys? We'll do one thing. Explain clearly about IPv6. First, we'll take example of global unicast. Global unicast range is what? 2,000 double colon slash 3. 2,000 double colon slash 3, right? You know what the 3 indicates? So here 3 indicates, so first 3 bits are fixed. So first 3 bits are reserved, not network portion. So for here first 3 bit indicates reserved bits. So first 3 bits indicates what? Fixed. So what are the first 3 bits? Tell me, what are the first 3 bits? 200 is wrong. Slash 3 indicates first 3 bits. 2 is a 1 hexadecimal, right? 1 hexadecimal number is equal to how many bits? 4 bits. Like out of 4, first 3 bits are fixed. Generally, how can I reset 2 in the bits? 0, 0, 1, 0, right? Like out of 4, 3 bits are reserved. 3 bits are fixed. Means 0, 0, 1 is fixed. Not change it. The result. Like fourth bit you can change. Either 0 or okay, either you can change 1, right? Already 0 is there. You can change as a 1. So first one is a 0, 0, 1, 0 is a 2. 2. 0, 0, 1, 1 is what? 3. The range of global unicast IP is like 2 to 3. The complete 2001 colon something like up to 180 bits, 128 bits. Later, if the series has been finished, now 3 will start. 3001 colon something like a 3 series. Now 2 series is being started after 20 to 30 years later. 3 series will start, right? So any IPv6 starting with 2 or 3, this IPv6 address we call what, guys? Global unicast is similar to what? Public IP address. So let me repeat one more example. FC00 double colon slash 7. FC00 double colon slash 7. What is slash 7 indicates here? Slash 7 indicates first 7 bits are fixed. What are the first 7 bits? F is a 1, 1, 1, 1. C is what? 1, 1, 0, 0. Out of 8 bits, how many bits are reserved? 7 bits. 1, 2, 3, 4, 5, 6. 7 bits are reserved. 8th bit you can change as a 1. The value is a FC to FD. So FC to FD is the range of a unique local address, which is similar to private address. The logic behind here. Okay, guys, that's all about for today. Finally, we have finished logical address, IPv4. I think next topic, next class, very very important topic. What protocol? So once TCP/IP is been finished, probably let me start with okay. So till now, the day one session, day two, and day, day two sessions is done. Three sessions, right? Monday, Tuesday, three sessions. Like out of three sessions, do you have any doubts? Like everyone is following, getting, everything is clear, right? Perfect. Same like how we are bonding with the subject, similarly with the remaining all the topics, all the technologies. Surely, at the end of the sessions, have a very good knowledge on. Yeah, we'll do practical also, practice also slowly, fast that we do the theoretically. Hopefully, from tomorrow, at the end of the TCP protocol, I'll do the practice. Anyhow, try to more focus on IPv4 network, IPv6 for next generation. Try to more concentrate on IPv4, so practice with more time with IPv4 network. Have a time more, then you can do the practice with IPv6 also. Yeah, we'll provide the exercises for IP addresses to do the practices. Let me start the practicals once, and daily I'll give the task.
Sir, one more question, sir.
Yeah,